Welcome back. This session we will see the second part of this object-oriented programming in Python, that is inheritance and different types of inheritance. So if we look into a real-world scenario, we used to inherit something from our parents, right? Yeah, some features or some characters we may inherit, the way of talking or way of walking or the color or the hair color, the eye color, something we may inherit from our parents. So the same thing can be implemented in case of object-oriented programming using this concept, that is inheritance. So we will see what is inheritance first and how we can use that in a Python program. We will see later. So inheritance is the capability of one class to derive or inherit the properties from another class. That is called inheritance. Just for example, here we have a class called vehicles. And 4 subclasses are there: bikes, cars, buses, trucks. So all these 4 are actually subclasses of vehicles, right? Yeah. So obviously there are some common properties of the vehicle which can be inherited by these bikes, cars, buses, trucks, etc. And that is called inheritance. Again, this bikes is having 2 subclasses: pedal bikes or motorbikes. So of course, some properties of the bikes will be inherited by these 2 different subclasses. Like that, every type of vehicle, again subclasses are there, and subclasses inherit properties from the parent class. So we can call it as the base class, and this base class, these are the derived classes. Bikes, cars, buses and trucks are derived classes. This is the base class. Like that, these 2 are derived class. For those bikes is the base class, like that. So what are the different benefits of using this inheritance in a programming language? First one, it represents real world relationships well. That is, if we think in a real world example, real world objects, those inherit some properties. That thing we can program as such into a Python program using this inheritance concept. And the second one is it provides reusability of code. That means there can be some code which is there in the parent class, which is inherited by all subclasses. So if we are using this concept of inheritance, we need not define it in every subclass. Once it is defined in the parent class, it can be directly used in the subclass without redefining it. So we are providing a reusability of code. Once it is defined in the parent class, there can be 100 subclasses. All these 100 subclasses can directly use it without redefining it. That is reusability. And the third one is transitivity. That is, if class B inherit from another class A, then all the subclasses of B would automatically inherit from class A. So in case of a real world scenario, if your father inherit some property from your grandfather, you and all of your siblings may inherit those properties from your parent, right? Yeah, that is called actually transitivity. We will see an example of how this inheritance can be used in a Python program. So we have a class called person. So this is a base class. Different types of persons are there, right? So in general, we can categorize all these people into a group called person. So we are defining the parent class as person, and we are saying that it inherits properties from object. You remember object, right? Yeah, that is the root class, so ancestor class for every object in Python. So there are some abstract properties or something defined in its object which is inherited by all the classes in Python. So there is no need of explicitly specifying in the parent class here. Otherwise also it will inherit all the properties of object into every class in Python. And we were specifying it as parent class here. And we are defining the init method here. Init is actually a constructor. At the time of creation of an object or instantiation of a class, this will be automatically invoked. So inside this init, we have 2 different assignments. First one is we are defining a new attribute name for this person, and we are assigning the first argument passed at the time of object creation into that variable. And the second is the ID number, another attribute this for this person, and the second argument for the corresponding instantiation will be assigned into that value. That is the first method. And second method is displaying these 2 attributes. So self.name and self.id number will be displayed using this display function. So this is different methods inside this person class. And we are defining another class, employee. So employee is obviously a subclass of person, right? Yeah. So employee, of course, all the methods and attributes defined within the class person will be inherited into employee, and employee will be having some separate or personal details or personal methods, like employee number may be there or employee job title may be there. So that are specific to this employee subclass, right? So we are defining it as class employee and specifying the parent class here person. Okay, so if we specify like this, all the public attributes and method defined in the person will be automatically inherited to the subclass employee. Okay, and here we are explicitly specifying or defining the init again. You can see here 4 arguments are there for this init: name, ID number, salary and post, but we are assigning this 2 attributes only, because these are 2 attributes specific to employee class. The other 2, the name and ID number, is common to all the persons, right? So those are actually defined within the parent class person. So specifically here we have to invoke 2 different assignments. One attribute is specific to employee salary. Into that we are assigning the 3rd argument value in the constructor method, and the 4th one, post of the employee, that is also specific to or private to this employee, right? So that's also assigned here. Self.post is equal to post. And what we are doing, that these 2 also should be assigned for every employee object, right? Name and ID number. Yeah, for that we already defined a method, init method, in the person class that we can inherit here. How we are invoking that? Person.init. So here the init, actually self.init, is the init method corresponding to employee class, and the class name, parent class name, that is person.init, we are calling or invoking the init method defined in the person class. So we are assigning with the first 2 arguments, name and ID number. So automatically what will happen? Again 2 attributes for this employee will be created. First one is name and the second one will be ID number. And the first 2 arguments in the constructor will be assigned to that 2 variables. So all the 4 variables will be assigned using these 2 methods. First one is specifically init method for this employee, and second we are inheriting the init method of our parent class person. Now your instantiation is done here. A is equal to employee means we are creating a new object A of the type employee class, and with 4 arguments. First one is our name, ID number, salary and post. What will happen automatically when this object is created? Init will be invoked, right? Yeah, self.salary will be self here, the corresponding object A. A.salary will be assigned the value here. What is the value in the 3rd position? That is 20,000. A.post will be the 4th argument, right? 4th argument is intern. So this will be assigned in this. So employee object A will have now 2 attributes, salary and post. The values are also defined. Then we are invoking this init method in the person. So what will happen here? This method, that is init here, will be invoked. So a.name is equal to the first argument here, right? Yeah, this is the first argument, that is Rahul, and a.id number is equal to this ID number will be assigned. So all the 4 attributes for this employee object A will be assigned now. Now we are calling a.display. A.display in the sense that we are not defining a display method here, right? So what will happen? The display method in the parent class, which is inherited by this employee object, will be invoked. So a.display, print a.name, a.id number. So the Rahul and the ID number, these 2 attributes will be displayed after invoking a.display. You can see the output like this. The a.name will be displayed first, then ID number also will be displayed. So this is how this inheritance can be written in a Python program. Now let us see what are the different types of inheritance available in Python. Simple inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance, and combination of these 4, that is hybrid inheritance. So all the 5 different types of inheritance are possible in case of Python program. So coming to the first one, that is simple inheritance. The simple level, one parent and from that parent a child inherit. Just for example, you can think of this is the father class and this is the child class. So child inherits properties from father, or it can be a mother class, it's a child class. So child inherit properties from the mother. That is a simple inheritance. And second one is multiple inheritance, that the same child class or same subclass inherit properties from multiple parent class. So you can think of this as father class and this is a mother class. So the child inherits properties from both father and mother. That is called multiple inheritance. Now coming to multi-level inheritance, different levels of inheritance. Okay, you can think about a grandfather class here. Father is the child. So father inherit from grandfather, child inherit from father. So child in turn inherit from grandfather. So that is a multi-level. Any level of any number of levels can be there in the multi-level inheritance. And this is a hierarchical inheritance. That means multiple subclasses inherit from the same parent class. So you can think about this as a father, and this is you and your brother, or you and your sister. So all the children of the same parent inherit from the same parent, right? That is hierarchical inheritance. And the combination of these 4 different types of inheritance, we have the hybrid inheritance. Right? Different levels of inheritance is there. Multiple inheritance is there. Multi-level inheritance is there. Simple inheritance is there. Everything is there. Just for example, child class 1 and child class 2 inherit from parent class. So that is hierarchical inheritance, right? And child class 3 inherit from child class 1. Child class 1 inherit from parent class. So in turn, child class 3 inherit from parent class. That is actually multi-level inheritance. Child class 1 inherit from parent class, that is actually simple inheritance. So every type of inheritance, the combination is also possible, that is hybrid inheritance. Now let us see each one in detail. First one is simple inheritance. There will be a direct parent class in from which the child class inherit different properties or methods. So we can see an example for that. We have a polygon class. Of course, polygon is a general class, right? Different types of polygons are there, like triangle, rectangle and everything. So each and every subclass, specific type of polygon inherit properties from the base or parent class, that is polygon class. So common methods, common properties we can define within the polygon class, and specific properties for each and every type of exact polygon that can be defined within the corresponding subclasses. So here we have a polygon class, that is a base class or parent class. Inside we are defining the init method constructor. Argument is number of sides. Okay. So what we are assigning in that constructor method, number of sides will be assigned to an attribute or property of this polygon, that is n. N indicates the number of sides of the corresponding polygon. So this attribute will be different for different types of polygon, right? For triangle it will be 3, rectangle it will be 4, like that. And one more thing we are doing inside this init function within this polygon, self dot sides is equal to 0 for I in range number of sides. That means we are initializing the number of sides within this init function itself. So depending on the number of sides, whatever argument we are passing, based on that much time we are appending zeros into a list. That is sides, number of sides. For each side, the initial value will be assigned as 0. That initialization also will be done inside the init program, init method. And the second method within this polygon is input sides. So we are reading the values or the measures of different sides using this input sides. So depending on the number of sides, whatever may be the number of sides, that much time we are reading what corresponding length of the side. Okay, so in case of a triangle, this will be invoked 3 times. Enter side 1, enter side 2, enter side 3. This much 3 times it will read the corresponding value from the keyboard, and that will be assigned to a list The name of the list is self.sides. Initially it was 0. Now we are assigning it to the values entered from the keyboard. And the corresponding sides, the length of the sides can be displayed using this third function, that is display sides. What we are doing here, for that much time, number of sides time, we are displaying the corresponding sides using this statement. So these are the methods in the parent class, that is polygon. Now we are creating subclasses. So first one is triangle. And inside the bracket we are indicating it as polygon. That means the parent class is polygon. So all the methods which are defined within this polygon are inherited by this triangle. So whatever method which are specific to this triangle need to be defined here. Other thing can be inherited from the polygon class. So you can see here in itself, the constructor corresponding to triangle, we are just defining as the corresponding parent init method. That is polygon.init means the corresponding parents init method that we are just invoking here with a second argument, that is the number of sides, as 3. We need not redefining it. Already it is defined here, right? Number of sides will be assigned to n, and this much time it is initialized. So just invoke the parents init class with number of sides as 3. That should be done for the triangle. And one more function or one more method which is specific to this triangle is find area. Because for different polygon, the area calculation will be different, right? So that should be defined within the corresponding subclass. So here in case of triangle, we have to apply this particular method for finding the area. So we are defining the method find area with first we are assigning values to these 3 variables a, b and c from self.sides. Self.sides, how will I get self.sides? Definitely that the value should be read from the keyboard, right? Self.sides, yeah. For that, at the time of creating the object, we can call this method input side. We will see how it can be done. Okay, so first input side should be called. It is already defined the polygon class. After that, we can call this find area. So corresponding values of the different sides of the triangle will be there in self sides. That will be assigned to A, B and C. The first value in this list will be assigned to A, second will be assigned to B and third will be assigned to C. That is actually unpacking of values from the list. Then we are putting the equation like circumference will be calculated first, that is semi-perimeter. Then the area will be calculated using this expression. Then the area will be printed. These are the statement within the find area. So only these two methods to be defined within the triangle. Actually here we are not defining it, simply invoking the parents class or parents init function with argument value as 3. Nothing else is done here. Here only one method is actually defined within triangle. All the other things like constructor initialization, input sides, display sides, all will be inherited from the parent class. So this is one example for simple inheritance. Triangle inherit properties of polygon. Now we'll see how an object can be created for the triangle and how these methods can be invoked from the parent class. You can see here we are creating a new object, instantiation. T is equal to triangle. We are creating a new object of type triangle class. And what we are doing here, automatically the init method will be invoked, right? Init inside the triangle will be invoked. So inside the init triangle method, init will be invoked. So value 3 will be passed. We are calling this function, invoking this method, right? Polygon.init. So going to this method, number of sides is assigned 3 now, right? That will be assigned to the attribute n, and that's my time, that is 3 times the 0 will be initialized to a list self.sides with 3 0 values. That will be done at the time of instantiation. After that we are invoking this method, that is t.input sides. Input sides is actually defined within the parent class, polygon class, right? So that is also we are invoking into this triangle object without defining here. So what will happen? We are reading the three values of three sides of the triangle, and that is assigned to self dot sides. Suppose we are entering three values like 3, 5 and 4. Okay, these three values will be assigned to that self dot sides, that is T dot sides. Now we are invoking this method, display side. That is also actually a method defined in the polygon parent class. That is we are inheriting into this triangle. Display side will display the different side values. Side 1 is 3, side 2 is 5 and side 3 is 4. Now what we are doing is T dot find area. Find area is actually a method defined in the child class itself, in the triangle class itself. So invoking that method automatically execute the set of statements, and the corresponding area will be calculated and that will be displayed here. So this is how simple inheritance works. Now coming to the second type of inheritance, that is multiple inheritance. In that case, the same derived class or the child class inherits properties from multiple parent class. So here we have two base class, base 1 and base 2, and the derived class inherits properties from both base 1 and base 2. So what about the features of derived? Derived can have its own properties and methods plus properties and methods of base 1 and plus the properties and methods of base 2. So we can see an example for this multiple inheritance. We have a parent class called calculation 1. So inside the calculation 1, we are defining a method summation. Summation, we are having two arguments and return a plus b. That is the function of this summation. Another class calculation 2, in which we are defining a method for multiplication. Two arguments are there. Return the corresponding product of those two arguments. That is multiplication. So we have two different classes, calculation 1 and calculation 2. And the third class we are defining it as derived. The name of class is derived. And we are specifying that two parent classes are there. Calculation 1 is there, calculation 2 is there. That means all the properties or method defined in calculation 1 and those in calculation 2 will be inherited by derived. Now we are defining a new method specific to this derived class, that is divide. Inside that we will return a by b. These are the two arguments, return a by b. So what happens, in effect this derived can have three different methods. One is summation, second one is multiplication, and the third one is divide. You can see here we are invoking this or we are creating an object for the derived class D, and doing or invoking the methods defined in both parent class D dot summation of 1 2. So 1 plus 2 will be returned. Actually summation is defined within calculation 1 class, that is inherited by D. Multiplication another one. Multiplication also defined by another class, calculation 2. That also we are invoking here. The third one specific to this derived class, that also we are invoking. So this is multiple inheritance. So what's the output here? We are passing summation with argument 1 and 2, right? So a plus b will be written, that is 3. 1 plus 2, 3 will be written. Then multiplication 1 and 2. So 1 into 2, 2 will be written. And 1 by 2, that is in case of divide, that is 1 by 2, that is 0.5 will be returned. So this will be the output for this invocation. And the third type of inheritance is multi-level inheritance. That is we have a base class A from which immediate subclass is the B, which inherit properties. From that again another class C, that is derived class, that inherit. So in turn C inherit properties from A. Both A and B C inherit. Okay, B inherit from A only. C inherit from both A and B. That is multi-level inheritance. So you can see here an example, class student. Student is a parent class in which we have a method student info, get student info. The roll number and name will be read from the keyboard. And print student info is another method inside the student that the roll number and name will be displayed. And another class BSc students, that is actually another class in which we are specifying that BSc inherit student class. So all the method, that is student info and print student info, get student info, both will be inherited by the class BSc. Again, a new method specific to this BSc class, that is get BSc. Extra information related to BSc, that is first we are reading the name and roll number using the parent class method, get info method. Extra information like physics mark, chemistry marks, maths mark, these are specific to BSc students, right? Yeah, that will be directly read using the get BSc function. You can see here, for reading name and roll number, we are not again writing the statement. Instead, we are just invoking the corresponding get student info of the parent class, that is student class. Other thing we are writing explicitly here. Another method within this BSc class, just to display all the details. There also, to display the name and roll number, already we have a method here, print student info, that we can simply call here. And for the rest, for the marks, we have to explicitly write the statements, marks in different subjects, like we can display here. So this is inheritance from student we are inheriting to BSc. Now we have another class result which inherit from BSc. BSc is the parent class for result, and we know that BSc is a subclass which is derived from student class, right? So in turn, this result class can use the methods and properties defined in both BSc and student, whereas BSc can use the methods and properties defined in the student. That's a hierarchy. So you can see that a new method specifically for this result class is get result. Inside the get result, already we have a method for getting the result in BSc, right? That is get BSc. Simply we are invoking it here without redefining it. Okay, so all the subjects marks can be directly read using this get BSc method, which is defined in the BSc class. And we have to find the total marks. Okay, for that we are simply calling the method written in the BSc class, calculation of total marks. That's simply calling here. So we need not defining anything here, simply invoke the corresponding method from the parent class. And another method, put result. There also we are simply invoking the method already defined in the BSc class for displaying the marks. Only the marks will be displayed using this print BSc function, but we need to display the total marks also. For that we are again giving a separate statement, print the total marks. Okay, so only for that we need to write a statement here. Other things we are inheriting from the parent class. You can see here that we are creating a new object student of type result. Okay, so the result is actually the derived class. For that we are creating an object student, and we are invoking the method student.getResult. Student.getResult in the sense it will come here, right? Get result. Yeah, get result. Actually what we are doing, we are invoking get BSc. We are coming to here. Inside the get BSc, what we are doing, it will invoke get student info. It's actually defined within the ancestor class, grandparent class, right? Yeah, here we are coming, invoking these two statements. So roll number and name will be read from the keyboard using these two statements. Now the student info is over. Coming back again here. Okay, the 3 marks, subjects of 3 different subjects will be read. Okay, so all the information will be read. Roll number and name using this get student info. Then marks of 3 different subjects using these 3 different statements. So get BSc is over. Coming back, so actually we are invoke get results, right? Get results. So that so after that, so all the attributes are read from the keyboard. Now we have to find the total marks. For that, this method is invoked. That is also defined in the parent class, BSc class. We are invoking this method. So now all the corresponding marks will be added up and the total will be calculated. That will be assigned to the self total. Then we are invoking the put result, the final statement in the student. You can see here, I cannot point that is why. The last statement, that is student.put result. Student.put results, display all the results, right? So for displaying the name and roll number, etc., we have the print result, print BSc, print BSc. What's print BSc? Yeah. Inside that we are invoking the print student info. For displaying the name and roll number, we have already the method defined the student class. That is we are invoking here. For displaying the marks, we have the separate statement within the print BSc. That is also will be there. After that, to print the total marks, what we are doing? Yeah, the total mark will be printed using this explicit statement. So this is a hierarchy of flow invocation of methods, right? Yeah, that is inside the put result we are calling the print BSc to display the marks of different subjects. Inside the print BSc we are calling the method defined the parent class, student class to display the name and roll number. So this is how the hierarchy moves. So you can see here. So you can see here, after creating the corresponding object of result class, we are invoking the get result. Inside the get result, roll number and name will be read using the students method. Students get info method, right? Yeah, after that, 3 subject marks will be read using the get BSc method, which is defined within the BSc. Then after that, for displaying the result, roll number and name will be displayed using the method defined the student class. Marks in different subjects will be displayed using the method defined in the BSc class, and the total marks will be displayed explicitly using the method defined in the derived class, that is result class. So this is how this hierarchy moves. Now coming to the third type of inheritance, that is hierarchical inheritance. That is different subclasses derive input or derive methods and properties defined in the same parent class. Here A is the parent class. 3 child classes are there, B, C and D. All the 3 inherit from A. You can see an example for that. Here we have a parent class. Within that we have a function. Simply just to demonstrate the purpose, okay? This function is a parent class. Just to display this information. This function is in parent class. Now we have derived class 1, child 1. That's a class is child 1. Within that we have a method function 2 which display the result. This is in child 1. And another derived class child 2 that also inherit from parent. So inside child 1 also it inherit from parent. Child 2 also inherit from parent. Parent is the base class here. And here we have another method function 3 which display the result. This is in child 2. So when we create an object, instantiation of child 1, object 1 is a object of child 1 class, object 2 is an object of child 2 class. Object 1 dot function 1 can be called because object 1 is also inheriting properties and methods of parent class. Okay, function 1 is actually a method defined in parent class which can be invoked in object 1. And this function 2 is actually defined in the child 1. That also can be invoked using this object 1, right? Yeah, these two statements for object 1. Whereas object 2 also the same thing happened. Object 2 is also a child of this parent class. So corresponding function, that is function 1, can be invoked by object 2. And function 3 which is specific to this child 2, that also can be invoked by this object 2. Now what about the... Now you can see the output. This function is in parent class, that is the first statement execute because object 1 dot function 1. Object 1 is actually object of this class. We are invoking the function defined in parent class. So this will be displayed. And second was function 2, object 1 dot function 2. Object 1 is this, function 2 is this. This function is in child 1. So that is the second statement. Then object 2 dot function 1. Again we are invoking this function 1 through the object of this class. Again this function is in parent class will be displayed. Then finally we are calling this function object 2 dot function 3. Object 2 belong to this class and the function 3 also belong to this class. So this function is in child 2 will be displayed finally. So this is hierarchical. Now combination of these things can be the hybrid inheritance. Okay? Depending on the application in our hand, we can program in that way also. You can see an example for that. Class school. We are defining a new class school in which we have function 1. This function is in school, just to display that. And student 1, another function 2. This function is in student 1. Student 2 is another class. All the two school student 1 and student 2 are child classes of school. Okay, parent class is school here. Here also parent classes school here. So this is an example for hierarchical inheritance, right? Yeah, instead student 3 inherit from both student 1 and school. That means multiple inheritance, right? So all type of inheritance are there. Now we are invoking this or instantiation of student 3 object. Now calling object dot function 1. Actually function 1 is defined within school, right? Function 2 is defined within this student 1. So all these type of inheritance are possible. So output will be accordingly. First is the student's function, then from student 1 function, like that. So these are different types of inheritance in Python. These are the differences from which I took examples. Thank you.